back to question 6. I am just back from my coffee break and now I'm slightly more energized. So we're going to tackle this question 6, which is 15 marks in total. But we're going to look into the first 8 marks first. Shall we dive into it? Okay. This is essentially separate science topic, and this is on acid bases and titration. So we have a setup of titration in case you need to have a visual image of how titration setup looks like. There's always the burette, which is the apparatus on the top, followed by the conical flask with the solution, either acid or alkali, in there together with an indicator. That's right. Alright, an indicator to help us see the color change, give us a color change so that we know that the end of titration has happened. So let's move into this question. So with this question, we are dealing with 2 different solutions. One is phosphoric acid, as phosphoric acid formula is over here. Then the other one would be our alkali, which is potassium hydroxide, which is more familiar to most students. Okay, so we have got these 2 together. And this is the student method. You can take a look over here. So they transfer the potassium hydroxide into a conical flask that looks like this. And then add the indicator, followed by fill the burette with the acid. Okay, the acid is in the burette. Okay, and then we add the acid. Okay, so yeah, so that's the setup. So this is the flow of titration. Again, it looks like this. Okay, and with that is they give you an equation. Okay, because you are dealing with an acid that is not really in the syllabus, which is phosphoric acid. So they give you the balance equation. And they ask for, the first question they ask is to suggest 2 improvements to the student method that will give more accurate results. So you're trying to wear your detective glasses here and try to be more precise, more accurate here. What can you do instead? So you're trying to find fault. You're trying to find fault in the student method and try to make it more precise. So the first thing you want to do here, you can see that the student first used measuring cylinder to measure 25 cm3. Now in the titration setup, we usually will want to use burette and pipette for higher accuracy. So instead of measuring cylinder, we can use a pipette instead, which can measure 25.0 cm3. Really very precise over here if you know how to handle it properly with the pipette bulb. Okay, so when you are answering this question here, they are only asking for 2 improvement, but it's worth 4 marks. Why is that so? It's because you need to take note of how you can answer. Okay, so this is how you're going to get the marks. So the first thing is you want to state the improvement, which is going to be in red, right here. I want to use pipette instead of the measuring cylinder. Then you want to talk about the why, okay? Explain why, that would be our 2nd mark. Okay, so why pipette? Okay, so this is because the volume of alkali added is more precise or more accurate. What are the other improvements that you can do? You can see that in this whole setup, there is no mention of white tiles, and white tile is really important when you have an indicator inside, because that will allow you to better identify the color change to tell you that the titration has completed. Okay. The other possible answer is when you are adding the solution, you should do a swirl. Maybe at the end of the video, I'll show you how swirling looks like. Okay, and this, why the swirling is important, or even stirring, okay, is to ensure that there's even mixing between the acid and the alkali. So as you add, you should do the swirling. And then finally, another possible answer is you want to add dropwise when it's closer to the end point. So this is the reason why for titration we do at least 3 times. First time is just a rough titration, so you have an estimated when the end point is like, is it like 26.5 or is it 27? So that when you are near 26.5, you will actually slow down and try to add the acid dropwise until you reach the end point. The reason for this is you can be very sure, or you would be very precise of where the exact endpoint is, and endpoint here refers to the volume of acid or alkali depending on which one you're using to neutralize the other. Okay, so this is how we work out this 4-mark question. Again, I'll try to remind myself to show you what swirling, concentration or titration calculation, and it's largely based on this mole concept triangle on concentration. Now, if you can take a pause and look at the formula of concentration. Concentration is always in mole per dm cube. Mole per dm cube. It can also be in gram per dm cube, really depends. Okay, but here we are using the units, okay, that is provided. You see, they provide the units to help you record this triangle. Since it's mole per dm cube, then it's obviously mole on the top and volume at the bottom. Okay, so dm cube is the unit for volume. So that's one way you can use the unit to help you record the formula. So we've got two different solution. Again, we have potassium hydroxide and phosphoric acid, right? So again, phosphoric acid is this and potassium hydroxide is this. I didn't create this balance equation, just want to let you know, I simply took whatever's on the top over here, okay, and I rewrite again, so we can refer to this balance equation as we do our mole concept. Okay, so do not panic. Okay, if this is an acid that has not been used very often in your syllabus, this balance equation will be provided. So with that in mind, what I like to do here is I like to make it a good habit to write down information that has been given to me. So I'm looking at potassium hydroxide, which is the one in blue over here. They have given me the concentration, and I've written it over here, 0.15 mole per dm cube. And they have done the same for phosphoric acid, and the concentration is 0.04. Again, I've written it right below my phosphoric acid. So what do they want me to find then? They want me to find the volume, and they were very clear that it must be in cm cube of the phosphoric acid. So whatever they want me to find, what I like to do is I like to give myself I put a question mark on the top of whatever I need to find, followed by the unit that they want me to present my answer in. In this kind of situation, again, this is like an exam tips for you. You minimize the careless mistakes that you will be making along the way. Okay, and they also ask me to put it in 3SF, so 3SF. I might write this down all in pencil as I'm working along my questions. So this is to get my brain to focus on how my final answer should look like. Okay, so what else do they give me is the volume. Potassium hydroxide. Okay, so again, I'm going to use blue. So it is of potassium hydroxide. They give me the volume, and I have written it on the top as well, the volume. And it's in 25 cm cube. Now, so take note, units is really, really important here. Okay, so with that, let's get moving. So what do we want to do here? So if you look at potassium hydroxide, which is this one, I'm going to turn to purple. Turn this to purple. Okay, my potassium hydroxide, I've got concentration, and I've also got the volume. And take note, I've got concentration, I've got volume. So that means I can actually find my number of mole of potassium hydroxide, isn't it? So what I need to do here is first, I need to convert my volume, this is my volume, to the same unit, to dm cube first, before I can multiply them. Because this 0.15 is in let me just rewrite the unit for you. It's in mole per dm cube, right? So what I want to do is to convert that volume to dm cube first, so I can kind of like just cancel off. So by doing that and I'm multiplying together, I would have 0.00375 mole of KOH. Okay, that's my first step. Then my second step is I need to find the relationship, what we call the mole ratio, between potassium hydroxide and between phosphoric acid. So based on the balance equation, it is 1:3. And you ask me, how exactly do I know it's 1:3? Okay, and this is when we look at what we call coefficient. Coefficient is just a fancy word, but basically it's just the mole ratio, the ratio between phosphoric acid and KOH. So you see that in front of KOH there's this number 3 here. So what this means is, it means that 1 mole of phosphoric acid needs to react with 3 mole of potassium hydroxide. So this is what we mean by coefficient, this is what we mean by mole ratio. So it's 1:3, and I can get this from balance, this is from balance equation. And so with that, based on what I found in first step, if I have 0.00375 mole of potassium hydroxide, then I would need to have 0.00125 mole of phosphoric acid. Okay, so but that's not what they want me to find for phosphoric acid, right? They wanted me to find volume in cm cube of phosphoric acid. So I go back to the triangle over here, my triangle again. If I want to find volume, I simply need to take the mole over here mole divided by concentration. And you need to make sure they are in the same units. Okay, so my mole is in, of course it's in mole, and then my concentration 0.04 is in mole per dm cube. Okay, and I'll get a number, but why do I multiply by 1000? Is because 1 dm cube equals to 1000 cm cube, and because they want me to present my answer in cm cube, I need to make sure I do this multiplication by 1000, and at the end of the day I will have 31.3 cm cube. Alright, so again, take note, it is 3SF. These are small things that you need to take note for yourself. 3SF will give you the full 4 marks. If you present your answer like this, would you still get 4 marks? No, you will not, okay? If it's 4SF, unfortunately, you only get 3 out of 4 marks. So please take note of that. Alright, before, I think, yeah, the next part is going to be quite lengthy. So what I'm going to do here is I'm going to take a pause, okay, for question 6, part 1, and I'm going to show you how swirling looks like. Basically, as you add your acid or alkali into the solution, you should give a swirl in your conical flask. Unfortunately, I cannot find my conical flask. I am in the lookout for one. If you know where exactly to buy in Dubai, please let me know. So yeah, this is basically how swirling looks like. You have your solution evenly mixed to know that, to ensure that they mix really well and you have your good neutralization taking place in there. Alright, if it's all good, I'll see you in the next one for question 6, part 2. See you!